Hey guys, welcome back to my channel. So today we will discuss the problems question number 12 and 13 on invertible functions and from the book A Class Book of Mathematics. So our first question is, let f is a function from R to R be defined by f of x equal x cube plus 2, then so that f inverse from R to R exists and hence find the formula for f inverse. So first of all, to show that this function f has an inverse, we need to show that the function is invertible. And how to show a function invertible, we all know. So here I will show that the function as a bijective map. Then we can say that this function is invertible. So we are given f of x equal x cube plus 2. Then take f of x1 equal f of x2. If we can show that x1 equal x2, then we can say that this function is 1, 1. So by the definition of this f in this question, it will be x1 cube plus 2 and the right hand side will be x2 cube plus 2. So here plus 2 and plus 2 cancels out. Now x1 cube equal x2 cube. Now if we take this in the left hand side, then it will become x1 cube minus x2 cube equals 0. Now this is in the form of a cube minus b cube, and we everybody know that a cube minus b cube is equal a minus b. A cube minus b cube equals a minus b into a square plus ab plus b square. So here it will be x1 minus x2 x1 square plus x1 x2 plus x2 square. So either this part equals 0, either x1 minus x2 equals 0, or this will be equal to 0. But here we can see x1 square, this is a positive term, and x1 and x2 are two elements from the domain R. These are also positive and their multiplication is also positive. Similarly x2 square, here it is square term, it is also positive, and sum of all these positive terms will be not equal to 0. It cannot be happened. So this is not equal to 0. This part x1 square plus x1 x2 plus x2 square never equals to 0. Now since x1 minus x2 equals 0, therefore we can write x1 equals x2. Whenever we take f of x1 equals f of x2 and we find that x1 equals x2, then this function is 1, 1. So f is 1, 1. Now to show that this function is on U, so since f of x equal x cube plus 2, let us take this f of x as y equal x cube plus 2. Now we express x in terms of y, then we get y minus 2 equal x cube, and when we take cube root on the both sides, then we get x equal cube root of y minus 2. So let us take that this x is another function g of y, and it is given by the root of 1 minus 2. Now we have found that f is 1, 1. But since we have got x equal to root of y minus 2, so we can see here for any y belongs to real number, we get x belongs to real number. So for any y belongs to real number, we get x belongs to real number. So for y belongs to r, x belongs to r. That means f is onto also. Now, since f is 1, 1 as well as onto, therefore f is invertible. So, when a function is invertible, then their inverse is always exists. Therefore, f inverse from r to r exists. So, f inverse from r to r exists. We need to also find the formula for f inverse. So, here it will be f inverse is nothing but this function g of y. So, f inverse is defined as f inverse of x equal u root of x minus 2. So this is the question number 12. Question number 13. So that f is a function from r minus a to r minus 1 defined by f of x equal a plus x divided by a minus x is invertible. Also find f inverse of x. So the solution is, since we need to show that this function is invertible, so first of all we will show that this function is 1, 1 as well as only. Let f of x1 equal f of x2 for any two elements in the domain. Then by definition of this function, we will get a plus x1 divided by a minus x1 equal a plus x2 divided by a minus x2. So we will cross multiply it, then it will become a square minus ax2 plus ax1 minus x1 x2 equal a square minus ax1 plus ax2 minus x1 x2. Now the similar terms will be cancelled out. Here a square and a square cancels out, and minus x1 x2, these are also cancelling out. Now the remaining are 2a x2 equal 2a x1. So since twice a are constants and equal cancels out, therefore x1 equal x2. So whenever we take f of x1 equal f of x2, then if we find that x1 equal x2, that means this function is 1, 1. Now for onto, let us take that f of x equal y, then y will be equal to a plus x minus a divided by a minus x. Now again cross multiplying we get now simplifying the terms we will get since we need here x, therefore x will be equal to a into y minus 1 by y plus 1. And let us take this x as z of y equal a of y minus 1 by y plus 1. Now, since here in the denominator, if we put y equal -1, then it will be 0, and whenever the denominator is 0, then it will be undefined. So y will belong to the range, y belongs to r minus 1, then x will belong to the domain. So for y belongs to r minus 1, then x belongs to r minus 8. Hence, f is onto. So since f is both 1 as well as onto, therefore f is invertible. So f inverse exists. So here the inverse of this function f will be this g of y. So f inverse goes from, so f inverse will be defined as f inverse of x equal a into x minus 1 by x plus 1. Since we are taking this f inverse in the element x, therefore I am replacing the y by x. So the inverse of this function at any element x, it will be a into x minus 1 divided by x plus 1. So this question is also done. So that was the session. I hope you are enjoying, and if you have not subscribed to my channel yet, then please do subscribe to my channel, and thank you for watching this video.